Hello, greetings programs, and welcome to this webinar on Connecting to WebAssembly. I'm Jim McKeith, and joining me is Mark Hoffman of WebObject Software.
Hey, how are you doing?
Good. So you're living down in Paradise now. I'm still up in
yeah.
Need to come down and visit. Where is it you live now?
Curacao.
Curacao. And that's like down in the Caribbean, right?
Yeah, it's like the very south, like just a little bit north of Venezuela. It's like the ABC Islands, Aruba, Bonaire, Curacao.
Cool. I really have always liked the idea of moving someplace exotic, as long as I have good internet.
Most days we do. Sometimes it can be a little flaky, but...
Are you on Starlink, or is it a ground line?
No, not yet. It's fiber, but it's island fiber.
Okay. I've heard from people I've talked to who've got Starlink that are pretty happy with it. So
okay, that's good. I signed up for that. I think they're scheduled to launch, I think either later this year or maybe early next. So I signed up like for put the deposit down and everything. So they let me know when it's available, but we'll see.
So yeah, besides, we were going to talk about WebAssembly, which some people might be new to WebAssembly or not be familiar with it, but WebAssembly is, I don't know, the evolution of JavaScript or replacement of JavaScript. How would you describe WebAssembly?
Yeah, I wouldn't say replacement. It's an alternative to JavaScript. So I mean, JavaScript isn't going away, but the idea is to have something that's more natively pre-compiled into a binary that you can run in the browser while still being safe, of course, and not running any arbitrary code, right?
So previously, Microsoft had ActiveX controls that you could run in Internet Explorer, and there was Flash, and Java applets spent some time in the browser. But this is a natively compiled running in the browser, but it's not natively compiled to individual CPUs. It's like some sort of intermediate language.
Exactly, yeah. So ActiveX, so those were basically, they were compiled to Windows x86 code, and they just ran and they could do whatever they wanted to pretty much. And then like Flash and all that stuff is to a different extreme that is like, it's interpreted in a way and run in a sandbox, but it's separate from the whole web experience, right? Like from the whole browser model. And the idea with WebAssembly is that you're living in the same space as JavaScript, more or less, except it's not JavaScript.
But it's in the browser sandbox the same way JavaScript.
Yeah, so I guess like on some level you could compare it to Java or .NET in the sense that you have like some sort of bytecode that isn't really any specific CPU. It's like a made-up CPU specifically for WebAssembly. And then the browser goes ahead and processes that and compiles that just in time to run. And of course, the browser then can also run checks and verifications on what the code actually does, which you couldn't do if it's just a black box binary code for the machine, or at least would be very much more tricky to do.
So the browser actually has visibility into what WebAssembly is doing, like it does with JavaScript. Okay.
Exactly. Yeah. So for example, you don't have like access to like files and things like that. There's no APIs for that to call those. So that's a way of restricting. You can't have code that does anything bad because you just don't have the access for that.
ActiveX in Java was one of those ways before browsers had any local functionality outside the browser. People would be like, oh, we can do this, and now we can browse files on your local computer or whatever.
Exactly, yeah. And like nobody thought about how bad idea that was at the time.
Yeah, right. Now, I've heard some people refer to JavaScript as being like the assembly language for the web, and you have some other things that are transpilers where you can write it in one language and then transpile it into JavaScript.
Right.
WebAssembly replaces that idea. Is it a more low level than JavaScript and is designed
exactly. Really, WebAssembly is more the assembly language or the machine language of the browser. As in, again, like the JavaScript gets compiled and the browser checks what it does and generates native code to run fast. And that's the same with WebAssembly, except the WebAssembly already is more prepackaged and easier to compile than JavaScript, right? Obviously, the browser vendors put a lot of effort into making JavaScript compilation super fast, so things have gotten a lot better there. But still, it's still text you have to parse versus bytecode that's pretty closely matches to what eventual CPU code is going to be, right? So that's always going to be easier to process, quicker to process.
So what sort of languages compile to WebAssembly? In theory, anything could, but what are some of the languages that are out there that people might be using or familiar with?
The main language usually is C, of course. That's like the go-to. And then, of course, there's our languages that do that. And I think there's a few efforts. I think Kotlin is doing WebAssembly as well at this stage. But to be honest, I'm not really too well versed into what else is out there. So on our end, we have Oxygen, which is pretty close to Delphi. And then we got C#, Swift, Java, Go, and now Visual Basic that all compile to WebAssembly and all to other platforms as well.
Forgot you added Go. Okay, cool.
Yeah, we added that I think a year ago. Yeah.
So are you planning to add Rust next? That seems a big popularity in that one.
we got nothing to announce, but if we add something as a next language, it probably would be Rust. Yeah, I think that is pretty interesting. I know that Carlo, our compiler chief architect, is pretty interested in Rust and has been playing with that, but nothing at this stage. I mean, we just added the Visual Basic support last month. We shipped that, so we've got to take it slow because everything we do grows exponentially. When we add a new language, you get all the templates. You have now one dimension more, all the samples, all the tests, all the code completion. Everything is just like balloons out. So 6 languages already keep us pretty busy.
Oh yeah, and then of course you have to test all your libraries with each language, and yeah.
Yeah,
yep.
To a degree, yeah. But mostly because that's on different levels. Usually that stuff just works, but yeah, you still gotta support everything everywhere, basically.
We'll probably spend most of the time talking about Oxygen, but I'm curious though, what things you like about Swift versus Oxygen. I know you used to be very much a Oxygen fan, Pascal derivatives.
Oh, I still am. It's still my favorite language. So
okay.
Yeah.
I see a lot of people that get excited about new languages. I'm just curious, since you've spent some good bit of time in each of these, what your thoughts are.
Yeah, I'm of 2 minds of Swift. I really liked it when it came out, but I think it's going into a very weird direction. I don't know. It seems like it's been they try really hard to make it really complicated. So I'm not sure. I don't really like where it's going, but it's got some really nice ideas. Some of which we actually took over to Oxygen as well and to the other language. For example, one thing I think that makes it really nice is they have this thing called trailing closures, where basically, if you have an anonymous method, you have those in Delphi too, right? Where you can pass a method as part of a function call. So instead of having to have it inside the parameters and having the closing parenthesis at the end, you can just attach it at the end of the method, and it makes the method more look like a language feature, right? So for example, if you have if something, you do if condition curly brace, you got your code, and you got a curly brace end, right? And you could do the same with a function, with a method that takes a closure. You just call your method curly brace, then it's your code, and then you do end. So that's one of the really nice features they had early on that I really liked about Swift. And then there's some other things, but there's also lots of things that are taking into, they're going very functional these days too, which isn't really my cup of tea. At the time I see that code, like, what is this supposed to do? I have no idea.
I like learning other languages, and I learned to appreciate all the different things they have about them. And then a lot of times things like you said that, like, oh, that'd be great, and you want to bring it over either as a language feature, or sometimes you see a way of doing things that you bring over it just in the language in general. But I'm the same way though. Pascal's always been my favorite. It's the, what I go to. Sometimes there's reasons to use other language, but generally speaking, if it's not a reason I need to do something else. If I'm running a shell script, that's going to be a certain language, but otherwise, I go back to Pascal.
Yeah, I'm pretty much the same, except for one major code base. Pretty much everything rem objects is all Oxygen, so that's where I spend most of my time in.
Yeah. So now, for those that aren't familiar with Oxygen, it originally had a different name originally, and then it was a while Embarcadero sold it as Prism, right? And then it was Oxygen.
Yeah. So we started as Chrome back in 2004, I think. Yeah. And then at some point we got an offer we couldn't refuse, so we renamed it to Oxygen. That was around version 3. And also around that time, I think half a year later, we had an agreement with Embarcadero to bundle it with Red Studio, and so we branded that Embarcadero Prism, or first it was called Delphi Prism and then Embarcadero Prism. We did that for a few years, and that was back then when it was only Oxygen and only for .NET. And since then it's come a long way, obviously. I mean, we added all the other languages to it, all the other platforms. So it's been an exciting, 16 years.
Yeah, I bet. So it's Object Pascal based language that shares a lot of things with Delphi. So Delphi is a dialect or evolution of Object Pascal, and Oxygen takes from that and then builds on more as well. So if someone's familiar with Delphi, they're going to be pretty comfortable with Oxygen, it sounds like.
No, definitely. Basically what we did is we started with what was basically Delphi 7-ish, the state of the art back at the time. And basically we took that, because that's the language we back then used and loved. And basically, we took that set and we just kept adding new features on top. So even the first release we made back in 2004, 2005, already added a bunch of stuff, and we've been keeping iterating and adding new things. I mean, kind of like those trailing closures I mentioned and other things, pretty much every year or every month. So it keeps growing. But yeah, if someone knows Delphi, they're going to be instantly familiar. And to be honest, like most like Delphi language code is just going to compile as is, and we've got some options to make that even easier as well in some areas.
Okay. But okay, so I guess so it has like code that's very Delphi 7-ish, probably can move across pretty easily. It sounds like.
Yeah, to be honest, even code that's Delphi 10-ish is going to be fine usually. There's a few things we have that make anything that Delphi 7-ish is probably going to compile as is, more or less, just about code, of course, not the libraries you might be using and all that, right? But just the code syntax. But of course, like since then, the languages have diverged a little bit. For example, we added generics. We used the C# like syntax with the square brackets, and I think Delphi went a little bit a different way. I think that these constraints are a little bit different than Delphi later on. So we added compatibility options for that. So we have an option, if you say, okay, I want to do it the Delphi way, you can set an extra flag, Delphi compatibility, and that's a huge list of things that are a little bit different or like that we don't usually support, that we enable that way. But again, I think those are usually pretty much corner cases anyway. If you're just naively writing Pascal code, chances are you're just going to be fine. You're never even going to notice that it's a different compiler.
Yeah, I guess maybe I should mention why I always wanted to do this webinar. I'm not saying everybody should switch to Oxygen, but I like the idea of, like you mentioned earlier, it's nice to have multiple languages you're familiar with because each one has different advantages and disadvantages and different targets. And stuff like that. And so I see having Oxygen in your tool belt as a Delphi developer is a great way to add some other nuances. Specifically, we're going to talk about WebAssembly. So how you can use Oxygen to connect your Delphi applications to WebAssembly.
Exactly. So it's not about switching. It's not, I don't know, you have to pick one or the other, right? Just if you know Pascal and you want to write something for WebAssembly or some other thing, say you got to write something that runs as a Java applet somewhere, God forbid, then why not use a language that you like and you know well, right?
We talk to people about web apps is people think of it as different things. And so people a lot of times say full stack developer. And for a while I was like, what is a full stack developer? And then I'm like, wait, I was doing that before. I didn't know that was a thing.
Yeah, exactly. Yeah.
Full stack is the idea of the back end or middle tiers or whatever you want to call it, and then the front end. But when you're talking about web, that front end is in the browser. And so is the JavaScript or the whatever functionality running in the browser, as well as usually the idea is that if you can do CSS and HTML, all that stuff, the different tiers, different layers of execution there. So WebAssembly is running in the browser and talking to the HTML and CSS and stuff like that. Now, if you're doing WebAssembly with Oxygen, or do you need to know the CSS and HTML, or is that abstracted away? Is it visually done, or what does that look like for a developer?
Well, HTML, you pretty much have to know a little bit if you want to do anything in the browser, and CSS as well to a degree. I mean, there's other technologies that can abstract the HTML away from you. Say if you want to do ASP.NET on the server side to build your website and then embed some WebAssembly in that on the client side, you might get away with, I don't know, knowing less about HTML and CSS and JavaScript. But in general, you're still going to need those. You're not necessarily going to need much JavaScript because I mean you can do lots and most of things inside the WebAssembly. But chances are, even then, if you build something complex like with really detailed HTML and complex structures, you might still want to throw in a little bit JavaScript here and there, just like inside the HTML, just to glue things together. So it can't hurt if you know it, but it's not like you're going to be living JavaScript every day if you're doing WebAssembly. I mean, that's the whole idea, to not have to do that.
That's an interesting point, actually. So you're saying we do WebAssembly and have some HTML and then some JavaScript in the HTML. Can you write WebAssembly in the browser embedded like you would JavaScript, or it's totally a different paradigm, it sounds like?
What do you mean in the browser?
I'm just thinking if I view source on a web page, I can see the JavaScript embedded in the web page. That's not something you do with WebAssembly, right?
You can basically look at the binary, and I think like the web inspector console gives you like a disassembly view of these are the methods to be found inside this WebAssembly, but it's not like you can't see the source or anything like that, right? Because I mean, it all gets compiled to the CPU code, and that's all that's downloaded basically.
Let's go ahead and can we fire up Oxygen, and you could do walk us through a little
Yeah,
demo
sure.
here of doing this.
Yeah, share the screen. Let me this video out of the way here. Yeah, so what I was going to do is just going to create a new project here. So we got WebAssembly here, and so we got two options. Actually, got three options to look at later. So we got the plain module that doesn't do anything for you, and we got the code behind model that provides some technology to interact with HTML better. So I'm going to use that. Just going to create that. What you see here basically is you got a run-of-the-mill HTML file. It's pretty simple. Just an headline button and so on. And up here we load in the WebAssembly module, and that's what's getting compiled from compiler. So down here we got the code behind file. So for the index HTML file, we've got an index class that sort of gives you access to everything that's inside the HTML. So right here we assign a click handler on the OK button. We set some properties in the constructor, and that's it. Right. So let me run this off, and you see if I bring this back, you see the code ran here. So it changed the name of the caption of the button and then if I click the button, it's going to react to that as well and run the event handler we had here.
So that's interesting. It changed it after the page rendered. There was a little bit of delay there. Can you have it so it executes it as the page loads, or does it have to wait for the page to render, or how does that?
Yeah, no. So basically, what happened is here that basically on start it downloads the module and initializes it and then runs it. So that's going to take that takes a second or so because it's got to compile the module. But what you could do in theory is, of course, you could hide this and only show it after it's loaded, right? So I could put a div around this and set it to hidden, and then the first thing in the code I said remove the hidden flag of the div or something like that, for example.
You're probably not going to have HTML elements that you change immediately on JavaScript. You're probably going to have
exactly.
Those.
No, I mean this is a bit of a contrived example, right? Yeah.
Yeah, that makes sense. I didn't think of it. No,
yeah.
Basically, the same thing with JavaScript.
Yeah. So I think the one thing I like about having this in the template is that you actually see when it's loaded, because then when you can start interacting with it. Yeah. But yeah, like in real life, you wouldn't enable the button until it can actually do something, for example.
I see some JavaScript files there as well in the HTML file. Yeah,
so basically those are files that are generated for you. They just contain boilerplate code that's sort of needed to load up the modules. For example, you see here the module 14.initiate. This is what actually goes out and downloads the WASM file from the server, and then loads it up and compiles it and everything. And that's all inside those two JavaScript files. So those get both created for you and compiled. So the first one is pretty much that static, that's the same for everybody. And then the second one is specific to your module, so it knows all the classes that you have exposed there.
What is the overhead then of using WebAssembly? Would you want to not use WebAssembly for like really simple interactivity in a web page and like only reserve it for when they're getting really carried away with a really complex web app, or would it make sense to use WebAssembly for all?
Yeah, I guess it's a balance of what you consider simple and not simple, and how much you like or dislike using JavaScript. If it's literally like, I've got this static page, but there's this one button, if I click it, I want to change the caption, or I want to make Spark or something, then it might just be easier to use 2 lines of JavaScript rather than all this. But I think as soon as you have a certain level of complexity that goes beyond, oh, this is super trivial, I think it's pretty much a wash. You pick WebAssembly because you prefer it, and
yeah, I guess that makes sense. Like
fine.
If you had a pre-existing JavaScript script, you just want to drop in there and boom, you'd be.
Oh yeah, yeah.
So ActiveX components were specific to Internet Explorer, and I see you're running in Brave. WebAssembly, does it run across most browsers today, or all browsers, or what's the?
I think pretty much any modern current browser. So that excludes like IE6, of course, but any sane browser in use today supports WebAssembly at this stage. Yeah. As far as debugging from the IDE goes, you can basically use any Chromium-based browsers, because that's the standard debug API they provide that we use. So you can't use Safari or Firefox; they don't have the debugging infrastructure. But otherwise, the website itself works in Firefox and Safari and anything else that I can think of.
So what is it? Can we look in the browser and see what what this looks like from the developer view in the browser, where it shows us like source code and stuff?
Sure, yeah, we can see. Let's see, what do you want to see?
like the sources tab there.
So for some sources, I mean, here's all the things you saw that's published by the server, and then here, basically, here's the WASM file that was downloaded. And you can see it's processing here, and then it shows you all the functions and then entry points that are exposed inside the WASM. It's not really disassembly, but like a, I don't know, generated header file, you want to call it.
Yeah.
Like that.
So that seems like a lot of code there for we didn't do a whole lot. Is there an optimizer that reduces the size of that WASM file since we're only doing
of course, yeah. I mean, for one, this is a debug build, so it doesn't really do much optimization or even any, and there's debug symbols and all that as well, of course, so you can debug. But yeah, it's again, like we provide a basic runtime library that sort of gives you some basic functionality you want to use in proper Object Pascal or general object-oriented code that goes beyond what's just provided by the browser. That's of course there. But again, like, yeah, if you build for release, then a lot of that is going to get optimized away if you don't use it.
Okay. All right. Now, so what is the debug? How does the debug experience look like then?
Well, that's pretty much the same as it would be for any other project. So you can just set breakpoints as you would like. So let's breakpoint here, for example, hit run. And it's just going to hit the breakpoint, and then you can see your stack trace here. You can see your locals. And of course, you can step through. I'm not sure why this is a little too much steps. The thing is, I know these are all dynamic calls to the JavaScript, right? I think there might be some optimizations yet to be done for the stepping. But yeah, in general, the debugging experience is what you would expect.
And so, like, could you change the value there, or does it have to recompile? It would have to recompile, wouldn't it? Or if you were to change like the code, the title.
Yeah, to change this, no, I'm not sure if I could. Again, this is new territory because this is all. Yeah, I don't think that the problem is that the debugger doesn't have access to the properties here because those are dynamic. So I'm afraid those aren't really exposed in the inspector here. Because you got to remember, like at runtime, these are JavaScript. Like head is a JavaScript object, right? Like you don't really have any information. What does it like? The debugger doesn't have any information. What does this object look like? To like list properties like you would in a Delphi class or something. So you're a little bit limited there. But in theory, you could, I think, call functions if there was exposed here from the debugger.
Now, when you're writing the code, then does it? If I type body dot, does it give me style as an option?
It does, yeah. So we're hacking here a little bit. So let me show you how this works behind the scenes. So basically, you see inside the HTML, I put ID tags in on some of the elements here, right? So you got an ID button. And basically what we do at compile time is we go ahead and we generate a second source file. It also has a class index HTML. That's a partial class shared with your code. And here you have code generated for each of the elements. And here you actually have strongly typed elements. So it knows headline is a button, headline is a headline element, button is a button element. And so when you type, it knows what properties are available there. And of course, it also knows that those elements are there in the first place. But at a different level, and at runtime, those things disappear at this stage.
I like the idea of partial classes, and I like that you're hiding that away. But how did you get to that again? I saw you're showing it, but then I don't see.
Yeah, so basically we have this up here in the project. You can do other files, and then any files that aren't part of your project but were generated for you. There's a couple other scenarios on other platforms where that happens.
Name, huh?
Those show up here, yeah.
Okay, it has exactly the same name though. Okay.
No, basically it uses the name of the HTML file .path. Actually, it does have the same name. I just mentioned it. But yeah, that's coincidence. Yeah, but it's in a different folder. Basically, it gets generated somewhere else.
Okay. Okay.
We can do. I can do if I do a build. I can show you that. Oops, I broke something. If I do a build, there's going to be a phase somewhere where it says, yeah, process HTML. So basically, it's generating a new source file in our temporary folder where all the build detria stuff goes, and it's just sort of injecting this into the compiler as if it was part of your project, even though it wasn't.
Now, as you're editing the HTML, when is it you have to build before that updates so that you can use it from code, or?
Right now, that's updated on build. Yeah.
Okay. So if you made some changes to HTML, you'd hit build, and then you could edit the code would reflect.
Yeah.
That.
So if I rename this to headline 2, get an error first because now it changed, and then now after the compile, actually I'd have to compile it first successfully, and then I don't know why it doesn't. It's demo mode. I don't know what's happening here, but that should work in theory. I have to look into that.
I do know that you probably have been editing on this, on the whole thing recently. I used to work one place where my manager would always bring a customer in and say, "Hey, demo this new feature," and I'm like, "It doesn't even compile right now."
Yeah.
So I totally understand that. So what kind of using WebAssembly and Oxygen, you can add that functionality in the browser. For somebody that has an existing Delphi application where they want to add a web application to that, what would be like the ideal scenario? Would they just take their existing application and recompile it, and all of a sudden it works in the browser, or what would you think they'd probably want to do for that?
Yeah, it probably would be a little bit more complicated than that, because obviously if you're building a Win32 application with PCL and FireMonkey and lots of fancy stuff and Devexpress Grid views and whatnot. But the idea is that you could probably take your business logic pretty easily and use that either in the WebAssembly or put it somewhere on the server, and then have code in the WebAssembly that talks to the server and reuse that, right? But you wouldn't probably want to reuse your GUI code and things like that.
So if they had a data snap server running, or data abstract, or a RAD server, REST server, something like that, they could just, with their business logic in, they could then build a client in WebAssembly to connect to that.
Yeah, definitely. Yeah. So for data abstract, we do have a data abstract for JavaScript client implementation actually that you could use, and that's fully accessible from WebAssembly as well. And again, you have access to all the JavaScript object model and APIs that you have, right? So you can easily use that. And for data snap, the same. I'm not too familiar with data snap these days anymore, but I'm assuming you have some sort of REST-based API or something you can talk to, and you can use the browser APIs, the HTTP request APIs to talk to that and get the data.
Yeah, and we have RAD server, which is also a REST-based as well.
Yeah, the same with there. Yeah.
Now, what about, you mentioned Devexpress Grids? Are there grids that I can use that are like really nice and robust that I can take advantage of from a WebAssembly client application?
I'm not really sure. I'm not really familiar with what the component landscape out there is, to be honest, on the JavaScript side, because that's really not my area of expertise. But in general, again, the same goes. If you get a suite of components that work from JavaScript, you can use them from WebAssembly as well, right?
That's what I was wondering, yeah.
Yeah, but the level we're at here is basically we are code talking to the DOM, and that's it. Everything else that's one step away from what we're talking about here right now, right? So we don't have a GUI framework or anything like that. This is really this replaces the JavaScript part, but it doesn't replace the jQuery part or the, whatever other sort of libraries you might be using.
So you could use jQuery from WebAssembly?
I would think so, yeah. I don't see why you wouldn't. Again, like there's just some JavaScript space objects that you can use.
Yeah. So Hydra, Embarcadero's parent company, has Sencha and a couple other JavaScript brands. So it would sound like, in theory, I could use the Sencha grid from.
I would think so, yeah. Yeah, that might be interesting for try time sometime. Maybe not today, but
yeah, not right now. But yeah, we need to come back and test that one out. That would be really cool.
Exactly, yeah.
Okay. Now, so you could have some shared code between Delphi and Oxygen for the WebAssembly. So if you define like some objects or business logic, you could do that as well. And
exactly, yeah. So as I said, the language in Oxygen is pretty much a superset of Delphi, except for a few really tiny corner cases. So in general, if you got some pure Pascal or Delphi code that defines your business logic, or you had some math algorithm you want to reuse, or just like data model of your customers, orders, whatever classes, chances are you can just throw it in and it's just going to compile after a couple changes or with a couple if-defs if necessary. Yeah. And the nice thing is because Elements supports all these different languages, the same is true if you have something in C# that's like your business logic or some algorithm you want to use, you can just drop that in as well.
So you also have the Hydra project, which lets you combine languages or .NET and Delphi, .NET and native and stuff like that, right?
Yeah, I mean, that's like a quite different angle. So Hydra is about mixing Delphi, like native Delphi for Windows, .NET, and Java code in the same process. So say if you have a Delphi application and you want to use, say, you have one form you want to implement in .NET, so you can use WPF, for example, or you've got this legacy Java applet sort of thing you got to host, or not applet, but like a Swing thing that's written a decade ago that you want to integrate in the same application. You can use Hydra to basically make your application pluggable and then get those different platforms in there. But that's orthogonal to this, though.
Yeah.
But within Elements, what you can actually do is, though, is in terms of mixing languages, you can actually use all the languages in the same project. So you don't have to like, this is a C# project, this is Oxygen project. It's just an Elements project. So for example, here I could just go ahead and say new file. Let's say class, and then I could switch from Oxygen to say, what do we want? Say C#, for example. And now we got a C# class there.
Oh, that's cool. That's juicy.
So if you had existing, again, like say you found some code that does something you got to do on the net, at the algorithm is in C#, you don't have to translate it. You just drop it in and you're done.
So do you have
again,
some more?
Presumably it's going to.
Sorry, go ahead.
No, again, that's assuming it's going to compile for WebAssembly, of course, but language-wise, it can be C#. And of course, it's going to use, I don't know, some weird .NET API that's not going to be in WebAssembly, right?
Yeah, so that's a good point, is that the language syntax is one level of compatibility, but if you had some existing code that was making like Win32 API calls or something like that, or
exactly, yeah,
Windows messages, that would not work.
Yeah, no, I think it's always important to people often go ahead and lump together, oh, like C# and .NET, that's the same thing, or Java and the Android SDK, that's the same thing, but it's not, right? You got the language, and that's really just the language. And who do you talk to? What the classes are? That's your platform. So here we're on the WebAssembly platform, but the language is Pascal or C# or whatever.
Do you have any support for GUI frameworks, like VCL type frameworks with WebAssembly or something like that, where we can build it?
Sort of. We have a little bit of a prototype, and it's really not much more than a prototype. Let me show you that. So what we have is, we have like really basic Delphi RTL and VCL compatibility layers. And what we've done here basically is we have support for DFMs. So this is literally a DFM copied straight from Delphi, including the source code. I think pretty much the only thing changed here is the users clause. And let's see if we can run this. Oops, this worked yesterday. Oops.
You had the attributes applied twice.
Yeah. I think I messed that up earlier when I was playing with that. Oops. That's not this is working this morning.
You removed both instances of the export. Maybe you put one of them back.
Oh, I had two of them there. Okay, yeah, makes sense now.
I do that all the time, where I'm like,
but at least you saw the debugger was working, right? That's what I wanted to show you. Yeah, so basically, everybody knows this example, right? So it's just basically standard VCL DFM with a couple labels, button, edit, list box. And then basically in the background, the Delphi VCL wrapper creates the HTML for that for you and builds it up. And again, that's like a very limited prototype at this stage, but I think looking forward, if there's demand and interest, and that's something we're exploring and expanding.
Is the source code prototype included with it? So I mean, if someone's like, oh, I could get partway there and figure out the rest of it, is that something that they would have access to?
Yeah, that's all open source on GitHub, actually.
Okay.
Yeah. And actually, that same library actually works for a couple of platforms. So that works for native Windows, and I believe at this point for native macOS as well. So you literally could take the same DFM and T-form class, and it's going to work on all three of them.
Okay, that's great. Do you have some more involved demos that maybe show some other cool WebAssembly type stuff?
Not really that many. One thing I prepared yesterday I wanted to show you is we talked earlier about doing requests to a server. So I whipped up something here. So basically, this is the XML Http request, which is really misnomer because it's got nothing to do with XML really. So basically that's a ready-made object provided by the browser that you can just create an instance of here, and then basically tell it to grab a URL of a server and work with it. So basically here what we do is we just create a new instance of that. We assign 3 events, what happens when it's done, what happens if there's an error, and we could also get progress report if we wanted to, and then we just call open and send, and then basically the browser is gonna go out and download this URL from the server, and then when it's done, it's gonna basically execute this and replace this text on the website. So let me see if this one runs. I've managed to break that too. Okay, so if I hit click me, this is the text from the XML. And if I check here, that's the XML file it downloaded.
Okay. Okay. So actually go back to the HTML or index HTML.pass. If you
okay. Yeah.
The pass file.
Oh, the pass. Yeah, sure.
So I'm looking at this and I see that we're writing the code in the type declaration here. And that's something you're pulling off via the partial classes, right?
Oh, actually, no, actually, that's a new sort of newish language feature we added to Oxygen a while back, I think 2 or 3 years ago. We call it unified classes. So you don't have to separate the implementation and the interface anymore, but you still can. That just happens to be the style that I used here. You could go ahead and say constructor and you do like this, like the more traditional how you would have it in Delphi, right? With the implementation and the declaration separated.
Okay. I kind of like the unified thing, but I was just like, wait a second, that's different.
Yeah, no, yeah, I like it too. I was gonna say I use it like I want to say 75% of the time. So it depends on what I'm writing. Like if I'm writing something that's very much this is an API for someone else to use, then I sometimes like to still have it separated, like to have a list of the function at the top. But if it's just like a class on its own that's just going to be there, I usually prefer the unified way. It's less clutter, but again, that's just like a personal choice. You can use whichever version you like.
Yeah. We remember when Delphi got the inline variable declaration and type inference and stuff like that. They're like,
oh yeah,
no, never use that, never use that. I'm like, it's an option, it's a choice.
Yeah, to be honest, it's a game changer. We've had this since the first version. It's one of my favorite features, actually, especially the type inference. Why type the tab name twice if you don't have to? Like,
yeah, exactly. And so that's the thing is, a lot of people are like, it's not clear what the type is. It's like, if it's not clear what the type is, then you're writing the code wrong. Then declare the type. But if otherwise, you're typing the type name twice, so you don't need to do that.
Especially, so like, what is gained if I add this here? This doesn't really help anybody. It just makes it more cluttered. So
exactly. And then if you change it in one place, you have to change it in the other place too, which is the other thing.
Yeah, that too. Yeah.
Yep, agree. All right, very cool. Was there anything else you wanted to show with this or talk about before we wrap up, I guess?
Yeah, so maybe a little bit background on how this whole debugging thing works. So one of the things about WebAssembly is that you, for some reason I don't understand, there's a little bit in the browser you can't load WebAssembly from a local file. It only allows you to load WebAssemblies via HTTP. So actually what we do, as you see down here, when you debug, we actually launch an HTTP server that basically serves this entire web folder. And then we send the browser to it. And that way, basically, the browser can load the index and the WASM file and anything else from that browser. And basically, that's where this request here goes to. Where is it there?
Right. Okay. So in production WebAssembly, there's no server element to it, but in debugging, you do have a web server, but that's all.
Even in production, your page is going to come from some server, so you're going to be fine. So, but what you can do is you can, I just have an HTML file on my disk and I double click it to open it in Chrome. And then for some reason, then Chrome says, no, I'm not doing WebAssembly here. That's insecure or something. I don't know what the reasoning behind it is. I don't understand, to be honest, but it's been there from day one, and I don't know why, but that's just something to know, basically.
Now, do you have to deal with the CORS cross-site origin scripting things and stuff like that? Is that something?
You do, yeah. So if I would change this to a remote URL, like some other server request would fail, and you would need the proper headers on the server and on your page or whatever that is to basically enable that. Don't ask me what those are right now, but you can Google CORS or cross origin and you can find that. But yeah, I actually ran into that when I created the example, because first I used an XML file or server. I was like, no, this isn't working. Oh yeah, there's the CORS thing.
I was looking at your string syntax there with the right line, and then you have the $ symbol, and then you have the square bracket or the curly brackets inside, and that's escaping it to say that's a concatenation there. So it's basically like a different format.
Yeah, those are interpolated strings. So basically, if the string starts with a $, then whatever you have in the curly brackets actually gets injected in those positions. So you get one string created from the whole thing at runtime. So it's basically just a quick way of writing string.format and then getting all your numbers right in the right order and everything.
Yeah. Okay, that's cool. Interesting. I love little language things like that. It's always interesting to see how different things do things.
Yeah, and also just for the record, I use the strings here have double quotes. So in Oxygen, you can use both. For some reason, I prefer double quotes because then I don't have to change gears when I switch in between C# and other languages in Oxygen. But this is here, single quotes work fine as well. So that tool is pretty compatible. So.
Yeah, JavaScript does that as well. You can use either type of string, which I thought was a nice touch.
Yeah, it does. Yeah. Also, it's nice if you just need a single quote inside your string or a double quote. You can just pick the right quote type that matches, so you don't have to deal with the escaping and everything.
But usually it's not a big deal. But I've had sometimes when it gets really awkward when you start to do multiple levels of escaping.
Especially if there's more than one.
Yeah. Or if you're doing like the empty quote, it says, okay, so I got to do escape and then
Yeah.
All right, very cool. So if someone wants to get started with some WebAssembly with Oxygen, what would they need to do?
Basically, just download a free trial version and get started. And I should say, like right now, I've been using this on the Mac, but this all works, of course, on Windows as well. We've got our own IDE for Windows as well. That looks pretty much the same, but it's all native for Windows. And also, if you do like Visual Studio, we integrate with that as well. So if that's your cup of tea, so those are the options for working in. But yeah, just download the trial and give it a go.
Okay. And so the trial comes with all languages then, is that right?
Yeah, it's all languages and all platforms, yeah.
All languages, all platforms. Okay.
Yeah, and then when you do decide to purchase, you can decide if you want just Oxygen or if you want basically the package with all the platforms for just a little bit extra, basically.
But we watched you build a sample here with WebAssembly. Is there some samples that it ships with that show some different use cases, or?
It does, yeah. One of them actually is this prototype that I showed with the VCL. There's a couple others as well, yeah. And basically, this is the starting point we started with. That's if you just create a new project from template, that's what's already there for you. So that helps you getting started as well. Yeah.
All right. And then you have documentation up on RimObject's website?
Of course, yeah. So we got docs.rimobject.com. You got documentation about all the languages and all the platforms as well. So this like details how the debugging works that we talked about with the server, how to talk to the DOM and to the browser objects and things like that.
Okay, fantastic.
Actually, that's another thing that might make sense to show real quick. Create another example there based on when we talked earlier. Close this. So basically here I've added a second method to the class for our page with method foo, and what that does is it just replaces the inner HTML again. And what I wanted to show you is that how you can just call this from JavaScript or from the HTML. So basically here I just added an href that just calls this method as part of the link click, and then that marshals into your WebAssembly code, and your method just gets run. So it can run this.
Interesting that you're telling HTML that it's a JavaScript call, but the JavaScript is going to be using the WebAssembly.
Yeah. I mean, basically, you can think of it as inline JavaScript. You could do the same. You could say foo, and then you have, say, function foo. Right, and that would be the same thing.
Now, is WebAssembly always object-oriented?
I think what you expose is always going to be a class with the, let me show this again. So you're going to have a public class with the export, and then all the public members are going to be exported.
Mm-hmm.
But you can add global methods to
Okay.
the code. That's no problem. So you could just go ahead and say, I don't know, and then do whatever you want.
Okay.
Yeah. Right. But really, I think being object-oriented is usually a good idea in general.
Yeah, I like the idea of object-oriented. I mean, it gives you the namespace type behavior as well, where you can.
Yeah. You get that with the globals too. But yeah, I think it's, I know, I'm an object kind of guy.
Yeah.
And maybe one other thing to show is basically, so we saw how you can call into WebAssembly from JavaScript, from HTML. You can do the same in the reverse. So what you can do, actually, no, you get this WebAssembly class that has some helper functions, and one of them is eval. And that's basically the same eval function that you also have in JavaScript. So you can put anything here that you can call in JavaScript and just call it. For example, let's just say bar. And now if we go in here again and say bar, we shouldn't do that. Oops. Oh. So if you blink, then this is going to call back into JavaScript again and execute the bar function. So you can go both ways. Mm-hmm. Your JavaScript can call your WebAssembly, and your WebAssembly can call your JavaScript.
Yeah. Interesting. I like this because it gives you have some clear delineations between what you're doing what. So that's nice.
Yeah. And then there's also there's another object that I was looking at. It's the browser object, and that gives you access to some of basically the root APIs that the browser exposes, right? So you can use the create element to add a new element to the code, or get element by ID you would usually use to, find the headline, for example. And you could go, append child and whatnot. And this is actually what's used under the hood for the code behind. So when we look at this again, you see this one just called get element by ID as well.
So everything that you give an ID, it gets and puts it in that code behind thing file.
Yeah, so basically it does the header, the body, and anything that has an ID that goes in there, yeah.
Okay. If you do, so you could put could you put JavaScript that runs dynamically in your WebAssembly? So write JavaScript, like maybe have something that's composing JavaScript and then have that JavaScript executed at runtime?
Yeah, that's actually literally what this is doing. So this is running this line as JavaScript. So you could do other stuff here. I know.
That's what I thought it was. I just want to make sure I was understanding correctly. So yeah.
Yeah. So yeah, I mean, in theory, you could put more complex stuff in there, like build a huge string with functions and nested, whatever not. And if the JavaScript engine can handle it, you can dump it in there and it's going to run.
All right. Very cool. So now you have I know a lot of people use RimObjects SDK, for example, for remoting and stuff. And that's something that is, if they're already using that, they can just plug that right into here to build a web client and talk to their backend server.
Yeah, so I said, so both for data abstract and for the remoting SDK, we have the JavaScript client SDKs, and you can just use those. You just add it up here. You copy it in your folder and include it as from wherever you put it. Include the RimObjects SDK.js file or data abstract.js file, and then you can use it from here. The same APIs that you would use from JavaScript, basically. So fetch your data table, call your remote methods, things like that.
Cool. We need to connect later and do a demo with Sencha and Rad Server. That would be great. actually.
That'd be great, yeah. And I'm thinking it would be good to look into actually having a demo with data abstract and the SDK as well, because that's something I know it works, but I never actually used it. Because as I said before, like I'm not really like WebAssembly isn't really my day-to-day cup of tea. So I don't really use it much for anything. So I learned a lot this week too, getting it. So.
Cool. All right. Yeah, let's plan on revisiting that. Maybe we just do a video on YouTube or something that shows that off or something like that. That would be great.
Yeah, that'd be great. Yeah, let's do that. Okay,
Well,
so any other questions you have or anything else you want to?
I don't think so. So we'll definitely do some live Q&A with the attendees. And
yeah, that sounds good. Yeah.
Yeah.
I do have a couple polls here actually as well that I wanted to do real quick, and then we will get into discussing some of these questions as well. So the first poll is just curious how familiar people were with Oxygen before today. If you had no familiarity at all, if you'd heard of it but not used it, maybe you used Delphi Prism or otherwise used Oxygen in the past, or if you're currently using Oxygen.
I mean, we can do a question and leave it running while we do, and then switch to the next one afterwards.
So you answered a lot of the questions we went along. There were questions about platforms, browsers, IDEs, and such. So from a IDE point of view, what are the people's choices for IDEs?
Right. So for IDE again, we have our own IDEs for both Windows and the Mac. You saw the Mac IDE Fire. That's what I've been using in the video. And Water is basically the same for Windows. It looks pretty much the same, except that it's a native Windows version of it. And then if you like Visual Studio, that's the third option or second option on Windows. We integrate with that. You have all the access to all the same features, debugging, all the code completion, all that stuff works the same in Visual Studio as well if you prefer that.
Okay. And then for browsers, it'll work in any browser, but then for debugging, it does require certain browsers, right?
Right. Yeah. So I mean, I don't want to say any. I mean, any modern browser like Firefox, Safari, all the Chromium ones that include Chrome, obviously, Edge, Brave, those all supported. I'm guessing Opera probably did it before everybody else. And I don't know. I mean, I'm sure there's probably some obscure browsers out there that might not, but in general, anything modern really does support it. And yeah, and for debugging, that's basically a design decision on our part. We're only supporting the Chromium debug API from our debugger. So you need Chrome, Brave, Edge, or again, any other sort of more corner case or more obscure Chromium-based browser is going to work as well, probably.
Okay. So I'll share the results of the poll. It looks like about half had never used it, and about half had heard of it but never used it. So
yeah, that's good turnout then.
A lot of new faces.
Yeah.
And even if you do the 4% that used it has Prism, it has changed a lot, evolved a lot more languages. The WebAssembly is new and such with that.
Yeah, that's it. Like back in the Prism days, we didn't have any other languages and any other platforms but .NET. So yeah, that's lots of new stuff there since then.
So the next question here is, what is the primary programming language that you use? Is it Delphi, Oxygen? Sounds like probably not Oxygen based on the last question.
Yeah, probably not.
JavaScript or other. Michael commented that Sintra with Rad Server and WebAssembly sounds great. Yeah, that would be cool. We'll definitely look at doing that.
Yeah, we'll be planning to do one of those over the next few weeks or so.
And David suggested switching to Zoom. We're actually looking at that currently.
Yeah,
there are
nice.
pros and cons of that. Not sure where we're going to end up on that.
So I see one question here that I didn't answer yet from Simon. Yes, can JavaScript call into methods from existing WA objects? Yeah, I mean, that's pretty much what I showed you when I got the page.foo. So page was the instance of our WebAssembly object that we created at the top of the file in JavaScript, and then when you call page.foo, that's basically JavaScript calling that method.
So results of the poll, it looks like predominantly Delphi, which I guess makes sense. But
yeah,
I was
shocked. Yeah.
About to see if it was C++ people versus Delphi people, since I guess is there really a C++? Well, you said that there is a C++ compiler for WebAssembly already, right?
I know that C is basically where WebAssembly started. I'm not sure if C++ supports it or not. I wouldn't know, but probably, I don't know. I don't want.
All right. Well, based on the results of these polls, definitely look at doing more Delphi related here with this. I do have one more poll question, and based on some of the comments here, probably might know the answer to this one as well. But what is everybody's interest in WebAssembly and Oxygen? Would you like to see more coverage of this, or you're like, yeah, don't care? So kind of so we have an idea. Like I said, Michael said that he'd love to see some Simsha XJS RAD server with that. All right, so it looks like it's about half and half on whether this was just useful or whether you'd like to see more coverage. So definitely looks like that might be something we were talking about doing anyway. So
yeah, I guess 7% we couldn't please, but that's okay.
So I will provide this as a download handout for everybody, but here's some more information on WebAssembly. You can go to webassembly.org, check out the roadmap, which shows the supported browsers and what features are supported in each browser, and FAQ specification if you really want to dive into that. For more information on Oxygen, you can find some links here on elementscompiler.com and rimobjects.com/TV. The documentation and such. And then also we have a special offer, or Mark has a special offer for you from RimObjects. If you go to rimobjects.com/shop, you can save 20% off any new Oxygen or Elements license. I put the pricing and options up there for everybody to see. And this is only available through into July and webinar attendees. So that gives you plenty of time to download the trial, play with it, and then make a purchase. Let's see, some other questions here. Do you have a visual form editor?
Yeah, at this stage we don't. So as I said, like right now we're focusing on basically we are replacing the JavaScript part of whatever we're doing, whatever you might be doing for WebAssembly. So again, you might be using ASP.NET for on the server and use the form designers there. You might be using some other visual designers to build your actual HTML or CSS. But what we're looking at today with the WebAssembly is that's literally just taking out the stuff you would write in Java, have to write in JavaScript, and instead you can write it in Pascal or C# or any of the other good languages.
Now you showed the VCL compatibility library and the ability to instantiate a DFM. So in theory,
right? Yeah. So with that, you could of course design your form in Delphi, and if you stick to what's supported by our library, then you could just copy it over or just reference the same file in your project and use that. Yeah.
So I mean, you said that the VCL compatibility layer was a prototype. If you were to estimate how much of the VCL is compatible with that, would like half, 10%?
I think it's pretty much the controls you saw. So like anything that's more fancy isn't supported yet, and of course anything that's like a third-party control that's going to be deeply Win32 based, and then there's like lots of stuff under the hood isn't going to be just able to, you can't just use that, right? But the idea is maybe we want to build an infrastructure where it's going to be easy for people to build components that can work within this infrastructure for all the platforms, or for just for the WebAssembly, depending on your needs. And yeah, again, like as you asked before, this is open for contributions. Yeah, I mean, this is open source, and we'd love for people to get involved and help us drive this, based on also like what kind of demand is there for this, right?
Yeah, and you know, we're testing the water with this webinar, and clearly people are interested in seeing some more, so we'll definitely do some more coverage. And I'm sure if Mark sees a bunch of people using that code and going out and buying it and asking for features, he will be certainly looking at doing more with that too. I mean, I'm not promising anything.
No, of course, yeah. Okay, so let's see if there are any questions we want to revisit.
There was FireMonkey, direct support from FireMonkey Delphi. There is not announcing anything, no plans. It's not on the roadmap, so stay tuned for that. But you know, again, if we see lots of interest, who knows?
Right.
That's how we decide, based on interest, for sure.
Yeah, so someone asked in terms of compatibility for platforms. Yeah, so this, again, like the browsers I mentioned, they work on Mac and Windows and Linux, so you should be covered there. And as far as CPUs go also, I'm running ARM on Mac here myself already, and it's running fine. And the same goes for ARM on Windows, as far as I know. Chromium works fine there, Edge works there, and the WebAssembly works inside that as well. So I wouldn't worry on that front. So unless you specifically still have users on IE6 or something like that, you're going to be fine with any of the modern browsers for WebAssembly.
Water and Fire, are they? I had to think about the name of the browsers or the IDEs. Are they ARM compatible, or they just work through compatibility layer?
Right now they work as compatibility on Windows, because basically Microsoft doesn't really have ARM support for either WinForms or WPF yet. So it runs in the 32 or 64, depending on the version of Windows you have, a compatibility layer. But again, that's the IDE, right? The browser, I'm not sure. I would assume that the Edge browser on Windows for ARM probably is native at this stage. So again, then the WebAssembly would run natively in there as well. And on the Mac side, we fully support ARM since last year, since it shipped. So Fire runs natively on ARM, the compiler runs natively on ARM, everything.
Yeah, actually, I have a Mac Mini, M1 Mac Mini that I've been testing on and loaded up stuff, and then the Windows compatibility really expanded. Worked, everything I've tested worked fine.
Yeah.
I'll have some videos and stuff coming out in the near future for that as well.
It's a great
I did bring up on the screen here, though. Here's the WebAssembly roadmap page, which shows what browsers are supported. Now, I'm not sure if it means that Firefox 89 is required, because I think Firefox 89, isn't that the current version of Firefox?
I have no idea, to be honest, but I think it's pretty close. So I think it's more like this is what the current one supports, and the older ones probably support less, maybe, or possibly.
Although most browsers are pretty good. People are pretty good at being updated anymore, because most browsers kind of just update automatically. And
yeah, you can pretty much not update them these days. Yeah.
Yeah, I suppose there probably are people that are in a very locked down IT environment that don't have the flexibility to change that. But
right, yeah.
Here's the page with the elements. There's all the languages that you support with the Elements browser, or the Elements compilers. Yeah, Elements compilers, and then IDEs.
They're further down, I think. If you scroll further down, yeah.
Now, do you have you don't have a Linux IDE though, but you could use the command line from Linux, right?
Yeah, you can use the command line to build on Linux, yeah.
Okay.
Yeah, we've got a couple of requests here and there for an IDE for Linux, but to be honest, it's a lot of work to port that, so the demand hasn't really been there.
Yeah.
Yeah, and it might be worth mentioning that Fire and Water, they're actually the same, literally the exact same code base that gets compiled natively for Cocoa on the Mac and for WPF on Windows. So what we would do is basically find a way to port that code base to use, I don't know, GTK Sharp or GTK or whatever is the current flavor of the month on Linux for UI. And so that's a little bit of a tough story at this point, because that's
So a good question, is that using an abstraction layer to handle that shared code base?
It's using a little bit, but not really that much. I mean, we've got this. We didn't cover this. We've got this. We call it Elements RTL compatibility layer. That's it's like a library that provides a lot of sort of common use classes like XML document, dictionaries, lists, some common helper functions on strings, things like that. So basically what you can do is if you stick to using that library for most of your code, you can pretty much just write naive code and not even think about it, whether it's going to run on .NET or on Cocoa or on native Windows. And that's what we pretty much did. So basically Fire started out on the Mac, it was pure Cocoa, and then I switched it over to use Elements RTL. And after that, it was pretty much a matter of doing a few tweaks here and there to get things working on .NET. And of course, all the GUI is native for Windows in Fire, so that part isn't shared, but all the other code is shared.
So there's a question here about performance benchmarks between suggesting things like machine learning or OpenGL. I've seen, so you mentioned that people are always the browser people are always optimizing with JavaScript support. It's one of those. I really dislike benchmarks.
Yeah, don't trust any benchmark you didn't fake yourself, right?
Yeah, my goal is always to. I get people all the time. They're like, "Can you do a benchmark between Delphi and this?" And I'm like, my goal in doing that benchmark, even if it shows Delphi is faster, is to say they're both fast, right?
Yeah. And the thing is, I mean, I could write a piece of code that compiles in Delphi and Oxygen, and it's going to be really good in Delphi and really bad in Oxygen, and I could do the same differently, and it would be the reverse, because I mean, each platform has their different paradigms, and you got to optimize. Like when you hit those corner cases where there are performance difference, you can optimize them per platform, but you can do bad things on any platform with any language, right? So
yeah, exactly. So I would say that performance-wise, everything I've seen, it's a bit of a back and forth. You'll see one day it'll be like, oh, this WebAssembly is now faster than JavaScript, and then next day you'll be like, oh, Google just added this new feature in JavaScript, and now it's faster than WebAssembly.
Yeah.
So it's a margin of error, I would say, in the difference in performance. But effectively, it is performant and is going to be as performant as you need for that. Yeah,
but I guess from what it says down here, there's C++ support for WebAssembly apparently, because they say C++. I don't know what compiler it is. Probably Clang or GCC or something like that. But
the one thing that I've heard a lot about actually is the security. WebAssembly has kind of a more emphasis on security, because in JavaScript, I mean, people can obfuscate it, but you can deobfuscate it. Technically, you could decompile WebAssembly as well, but that's kind of one of the things that they've put a little more emphasis and focus on in WebAssembly is.
Yeah, I would imagine that even if you decompile, I don't know, minify JavaScript versus WebAssembly, you still probably get more useful information out of the JavaScript than out of the WebAssembly. I would imagine.
Yep. So there's a question here about pricing for updates and support on Oxygen. Let's see, pricing. Bring it up here.
Yeah, so basically those prices we saw there for the first year, and then for the additional years we have renewal pricing that's lower.
Okay, but that's not on here. So the first year would be $7.99 for the developer license.
Yeah, and that's for all languages, and for Oxygen it's $5.99, and then subsequent years would be $6.99 or $4.99 to renew. And also there's academic and personal editions as well that are much lower price. If you're not using it commercially, or if you're working in an academic setting, then those might be options for you. And of course, if you're in a big company, there's the site license also.
Oh, you have a monthly option too.
Yeah, that too. Yeah. We started adding that.
That for C++ Pro, kind of experimenting with that. A few people have asked with it for it, so we're just like, okay, well, let's see if it's going to work.
Yeah. I got to say, though, that the discount code doesn't work for the monthlies, mainly for infrastructure reasons, because that's sort of using a different sort of system.
Sure. Does it work? So it works on personal and everything else?
Yeah, it works on any of the regular purchases, just not on the monthly, because the monthly recurring license, they're basically, you're going to be charged automatically every month. And so that use a different system, but all the other ones are you just buy it and you never get bothered again. If you don't want to renew, you don't have to renew, and you don't have to cancel or anything like that.
Okay, I think that is it for the questions. Thank you everybody for joining us today, and based on the results of the poll, we'll definitely look at doing some more on this, either a webinar or at least some videos. Probably a webinar.
Yeah, thank you everyone.
Yeah, all right, take care everybody. Bye.
Bye.